So the worst is over, folks. I've got one more thing to do. I got a 1 up here and used it to get zeros underneath it. I got a 1 here and used it to get a 0 underneath it. And I got a 1 here and used it to zero out what's above it. Now I'm going to use the 1 here to zero out what's above it. And all I need to do is replace row 1 with row 1 plus row 2, and that'll take care of it. Alright, so I'm going to replace row 1 with row 2 plus row 1. So row 3 I'm keeping the same. Row 2 I'm keeping the same. And row 1 now I'm going to get by adding row 1 and row 2 together. So 0 plus 1 is 1. 1 plus negative 1 is 0. 0 plus 0 is 0. 17/29 plus negative 21/29 is negative 4/29. Negative 35/29 plus 62/29. Well, 62 minus 30 is 32. 32 minus 5 is 27. So it's 27/29. And negative 8/29 plus 15/29 is 7/29. So if we've done everything correctly, since I've got the identity over here, I know that the matrix A is invertible, and I know that the A inverse is this guy. And I could check that by multiplying A times A inverse and A inverse times A and checking that I get the 3 by 3 identity. But I'll leave that to you to do in the privacy of your own home. Now that we have A inverse, we can go back and finally solve our systems of equations. Okay, we're on the home stretch here. As we mentioned before, we can take this system of linear equations. If I let A be the coefficient matrix, X be the matrix of unknowns, and B be the constant matrix, this system is equivalent to this matrix equation. To solve the matrix equation, I take A inverse times B. So this is the A inverse we found through tedious computation and row operations. And I'm multiplying it by the constant matrix B, and then my solution should show up over here in this matrix. So I multiply through, and let's just focus on the numerators because the denominators will all be 29. I've got negative 4 times 1 is negative 4. I've got, so we'll keep a little tally up here. So I have negative 4. I have 27 times negative 3. So that would be negative 60, negative 81. And I have 7 times 8, 56. So that would be negative 85 plus 56. So 56 and 20 would get us to 76, and another 9 would get us to 85. So this is negative 29 over 29, which is negative 1. Multiply the second row times the column. I've got 17. I've got a negative 35 times a negative 3. 3 times 35 is 90, and you add 15 to that, you get 105, and that's a positive 105. And then I have negative 8 times 8 is negative 64. So if I add those together, this gives me 122 minus 64, and 122 minus 64, well, 64 and 50 would get me up to 114. I need to add another 8, so that'd be 58, and 58 over 29 would give me 2. And last but not least, I have 7 plus 33, which is 40, minus 40 is 0. 0 divided by 29 is 0. Alright, so that gives me my solution is negative 1 to 0. And you can check that solution by going back to my original system and substituting in x is negative 1, y is 2, and z is 0. Now if you go back and look at your work from Checkpoint Quiz 8.2, if you follow through the algorithm as presented in the book, you'll notice that you're using the same row operations to find the inverse matrix as you did using an augmented matrix to solve it. And what the A inverse then is really doing is keeping track of the net result of all those row operations, so that if you wanted to change this system, let's say these were 3 parameters, like budgetary constraints, you could change the system and have a 3, a negative 2, and a 15 here. And instead of having to redo the row operations, all you'd have to do is redo this multiplication. All right, so this helps you do sort of parametric analysis of things. So that'll do it for Checkpoint Quiz 8.4.